Okay, so this is 4.3, and this will be the last section before our quiz. We introduced it a little bit on the Google Meet today, but the title of the section is Writing Equations Parallel and perpendicular lines. Writing equations of parallel and perpendicular lines. And what we are talking about with parallel lines are lines that look like this. Parallel lines never intersect. Now you can look at those and say, hey, those look like they will never intersect, but one of these could be slightly off and they could indeed intersect. What makes them parallel is parallel lines will have the same slope. They have the same rise over run. So if I have the same rise over run, my rate of change is constant in both of them. It's never going to vary from that. They will have different y-intercepts, but their slopes will be the same. Parallel lines have the same slope. And we're going to break these down and look at both of these kind of together. But we're going to break it down. We're going to look at parallel first and perpendicular second. So a parallel line just quick little definition. Two lines, and they have to be in the same plane, so they're going to be in the same coordinate plane, that never intersect. They're never going to cross. Parallel lines are two lines in the same plane that never intersect. And we mentioned this earlier, and the big thing we want to take away is parallel lines have the same slope. So I can certainly prove that two lines are parallel by comparing their slopes. And I can do that off of a graph by looking at rise over run, or I could do it by looking at change in y over change in x. Here's how we're going to use these. So here's our first example. You are going to write an equation of the line that passes through 5, -4, and is parallel. And I am going to start using that symbol right there for parallel. Two lines, looks like the number of 11. Those are just parentheses there, but this is the symbol for parallel. I'm sick of writing parallel already, so I'm going to use this. So we're going to write an equation of line that passes through +5, -4, and is parallel to the line y equals 2x plus 3. So there's our problem. We are going back to writing in y equals mx plus b. And just like what we did before break and what we brushed up on earlier in this week, we have y equals mx plus b. In order to write in y equals mx plus b, we need a slope and we need a y-intercept. So here you have this line that passes through 5, negative 4, but it's parallel to this line. So if you just get like a little visual on it, let's think about that real quick. I'm going to do this so quick, but I just want us to see it. If I have 2x plus 3, and I just make a quick little xy coordinate plane, you have a y-intercept of 3, a rise of 2, a run of 1. So I've got that line right there. That's 2x plus 3. Then you have 1, 2, 3, 4, 5, 1, 2, 3, 4, a line that goes through 5, negative 4, and is parallel to that line. So it's going to look something like that. Now, I know 100% this isn't to scale, but this is what we have going on. This is given the equation. This is y equals 2x plus 3. This is what we're being asked to write the equation of. And I know that if the two lines are parallel, they have the same slope. And I have a point that this goes through. And once I have slope and I have an ordered pair that it goes through, I can certainly solve this. And that's what we're going to do. Not solve it, write it. So here we go. To write the equation for my new line, you know your slope is going to be 2 because it's parallel to that line. I don't know what b is. You have an x and you have a y right back from up here. Here's your x, here's your y, just like what we did before. X is 5, y is negative 4. And we're just going to use it just like what we did before. Y equals mx plus b. Plug these in. Y is negative 4 is equal to my slope 2 times my x of 5 plus my b. Negative 4 is equal to 10 plus b. I would subtract 10. Negative 14 then is equal to b. You have the two pieces of the puzzle you need to write the equation of the line that passes through 5, negative 4 and is parallel to the line y equals 2x plus 3. And notice, the line that's parallel to it should have the same slope in a different y-intercept. My slope is the same of 2, and it absolutely should be because that's what I used and I took it from. My y-intercept is what's going to be different. So the equation of the line that is parallel to that, passing through 5, negative 4, is 2x, subtract 14. So as you can see, we're just going to take the slope from the line that it's parallel to and then just find our b. Next example. We will say this, a line, and we will call this, I'll call it line A, passes through, line A passes through, I will say negative 5, 3, and negative 6, negative 1. There's one line. And now I'm going to say another line. We'll just say another line. And we'll call that B. And I'm going to use the same thing. Passes through. Give you a couple more ordered pairs. 3, negative 2, and 2, negative 7. The question is, are the lines parallel. And again, you could certainly plot those points in a coordinate plane, connect your dots, make line A, make line B. They might look like they're parallel, but I would not know for sure if they're parallel unless I counted my rise over my run, unless I found my slope. In order to be parallel, they have to have the same slope. Yeah, I'm in no mood to start graphing these, but I can absolutely find the slope by just using change in y over change in x. So I'm going to look at line A. I will write out my points. I have negative 5, 3, negative 6, negative 1. Because these both lie on that line, I will circle my y's because I am going to find my slope by doing my change in y over change in x. And I have 3 minus a minus 1 divided by negative 5 minus a minus 6. Be very careful with your subtraction here. On the worksheets that you guys turned in, finding the slope was one of the biggest issues, and it had to do with these negatives. Be careful, because if I'm going to tell if they're parallel, I got to calculate my slope right so I can make that comparison. Minus, minus, slash, slash. Minus, minus, slash, slash. I'll do the math. 3 plus 1 is 4. Negative 5 plus 6, 1. Leaves me with a slope of 4. If I get a slope of 4 for line B, I'll know that they're parallel because parallel lines have the same slope. So again, I have 3, negative 2. I have 2, negative 7. I will do my slope by change in y over change in x. That's why I'm circling my y. So slope would be negative 2 minus a minus. Let's make that a little clearer. Minus a minus 7 over 3 subtract 2. Minus minus slash slash. Negative 2 plus 7, 5. 3 minus 2, 1. I get a slope of 5. I am confident those are correct. So to answer our question, are they parallel? Well, do they have the same slope? They don't. So they ain't parallel. Why aren't they parallel? They do not have the same slope. No, they do not have the same slope. When you're asked to tell if two lines are parallel, see if you can compare their slopes. Doesn't matter. If I give you an equation, you could identify slope. Y equals 3x plus 2. Y equals 4x plus 2. Are they parallel? No. They don't have the same slope. They got the same y-intercept, but they got different slopes. Compare your slopes. That is parallel. Big takeaway, parallel lines have the same slope, and we can write equations of lines that are parallel to each other by figuring out a slope, using that slope, and taking the information given so I can find my B. The flip side of this, perpendicular. Perpendicular lines. Perpendicular lines are going to be two lines that intersect in the same coordinate plane, and perpendicular lines are going to form right angles where they intersect. They're going to be 90 degrees. There is something special about the slope of these perpendicular lines, just like parallel lines. So with our parallel lines, we knew that they were parallel if they had the same slope. With perpendicular, it's going to be a little bit different, but we're going to define it right now. So perpendicular lines, and I am going to abbreviate perpendicular just like this. It's got a line coming down. It's like an upside down capital T. I'm going to use that to represent perpendicular. Perpendicular lines. Definition: two lines in the same plane. So we're going to have them, they're going to be in the same coordinate plane that intersect at right angles. It would be 90 degrees. Remember, right angles are 90-degree angles. Two lines in the same plane that intersect at right angles at 90 degrees, they are perpendicular. Perpendicular lines have slopes that are opposite. Opposite. Remember, another word for opposite is we take the negative of it. But they are opposite reciprocals of each other. They're opposite reciprocals of each other. So if I have something that has a slope of 2, the perpendicular slope would be the opposite reciprocal of 2. Remember, that's 2 over 1. I flip it and make it negative. The opposite reciprocal of 2 is negative 1/2. If I have a slope that is negative 1/4, and I want to know what's the slope of the line that's perpendicular to it, I take the opposite reciprocal. The opposite reciprocal of negative 1/4, the opposite of a negative is a positive. I would flip that. It is 4. The opposite reciprocal of negative 2 is a positive 1/2. Flip it, take the opposite sign. And we are going to use that little bit of knowledge to start writing some equations. So here we go. We are going to say, are the lines, and they're always going to tell you in the book or on the test, this is a big test question. This is a huge chunk of the quiz and the test, which you're going to be asked to do. Question just like this: are the lines, if any, parallel? Here's my symbol for parallel. Or perpendicular. So we're going to be given some information, and I want to know, are these lines parallel or perpendicular? Equations of 3 lines. Y equals 4x plus 2. X plus 4y is equal to 3. Negative 8y minus 2x is equal to 16. And we want to know, are any of these parallel to each other, or are any of them perpendicular? And when you're given equations, Even if you graph these, you still can't prove that they're parallel or perpendicular unless we look at the slope. And I know if I find the slope of each one of these, and the slope comes out the same, they're going to be parallel. If the slope comes out opposite reciprocals, they're going to be perpendicular. Or it could come out where they're neither parallel or perpendicular. But in order to compare slopes, you can see these equations. Wouldn't it be helpful if these suckers look like y equals mx plus b? Because then I could determine my slope and I could determine my y-intercept. I don't really need my y-intercept. I really need to compare my slope. So if I look at the first one, it's in y equals mx plus b. I know I have a slope of 4. Here's where I'm going to start my comparison. I've got 1 with a slope of 4. In order to find the slope here, I would solve for y, which means I will subtract x. 4y then would equal negative x plus 3. I would divide everything by 4. Y then is equal to negative x over 4 plus 3/4. Here's my slope. Remember, dividing by 4 is like multiplying by 1/4. So my slope is negative 1/4. And I've got a y-intercept here of 3/4, but really, I'm concerned with comparing the slope. Don't sleep on this part, man. You're going to get a lot of these when you're solving for y. Slope is negative 1/4. I've got a slope of 4, negative 1/4. I'm going to solve for y here, which means I will add 2x. Negative 8y, that goes away, is equal to 2x plus 16. Again, I'm writing that x first because I want it in y equals mx plus b. I'm going to divide everything by negative 8. Positive y then would equal 2 divided by negative 8. That reduces to a negative 1/4 x. 16 divided by negative 8, negative 2. I have a slope then of negative 1/4. Now I have something where I can make a determination. Let's see. Are any of these parallel? Well, parallel lines have to have the same slope. B and C have the same slope. Here's how we write it. B is parallel to C. B is parallel to C because they have the same slope. The opposite reciprocal of 4 is negative 1/4. The opposite reciprocal of negative 1/4 is 4. Flip it and change the sign. Flip it and change the sign. Opposite reciprocal, opposite reciprocal. When slopes are opposite reciprocal, we know that they're perpendicular. So I can say A is perpendicular, and I'll just say to both B and C. You could say A perpendicular to B and A is perpendicular to C. I'm just going to do it in one statement. A is perpendicular to both B and C because they have slopes that are opposite reciprocal. So again, you can see if you're asked this question, you have to take great care in finding your slope, because once you find your slope, you can make the comparison. If you mess up on one of these slopes, making these statements is going to be tough. Take care in finding your slopes and solving for y. Last example, we are now going to write the equation of a line that's perpendicular. And we're going to use what we did with the parallel and knowing what we know about perpendicular slope to write that new equation. So write the equation of the line that passes through the ordered pair -3, 1, and is perpendicular to the line y equals 1/2 x plus 3. So again, here's what we're kind of dealing with here, and I'll just do another rough sketch. You've got this equation, y equals 1/2 x plus 3. Y-intercept of 3, rise of 1, run of 2, down 1, over 2. And again, I know this is real rough, but that's okay. So there's that line. Perpendicular to it passes through the ordered pair -3, 1. So you've got some sort of line that passes through there, and we know that it's perpendicular to it because it tells us that it's perpendicular. This is the line that we know. This is the one that we want to find. Because they are perpendicular and the problem tells us so, I know that the line I'm trying to find has slope that is the opposite reciprocal of this line. That's the information I need to use. So again, we're going to figure it out. In order to write the equation of the line that's perpendicular to this line, I need a slope. Well, if it's perpendicular to it, it's the opposite reciprocal of 1/2. Perpendicular slope will be -2. You don't know what b is. You have an x and you have a y. Here's your x, here's your y. Your x is -3, your y is 1. I just need to solve for b now. 1 is going to equal your slope, -2. Remember, it's the perpendicular slope I'm using, times my x, which is -3, plus b. 1 is equal to negative times a negative, a positive 6, plus b. I would subtract 5, subtract 5, subtract 6. 1 subtract 6 is -5, is equal to b. Subtract 6. You have a b, you have an m. Equation of the line perpendicular to this line that passes through -3, 1, y is equal to a -2x, subtract 5. And when you're comparing these and it's perpendicular, your slopes better be opposite reciprocals. Versus on the front where it's parallel, your slopes better be the same with different y-intercepts. Here, same slope. This y-intercept is 3, this is 14, but my slopes are the same. Perpendicular slope, slopes better be opposite reciprocals of each other.